going to be on page 232 here. Okay, and we're going to be looking at linear models to help make a prediction. Okay, so we've talked about equations of lines before, and remember that's our y equals mx plus b, where m is our slope and b is our y-intercept, and that's where our line crosses the y-axis. So we're going to use those skills that we did with scatter plots now. Okay, so we have Michaela. She's a speed skater and hopes to compete in future Olympic Games. She researched the winning times of the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to be in 2026? Okay, because she's got a little while to go before she's actually at the Olympics. So they have plotted her data. So we have the time, the years after 1960. So this would be, 10 years later, so that would be 1970, 1980, 1990, so on and so forth. Okay, and then we have our times in minutes, so 1.6, and then it looks like we have like 1.8, 2.2, 2.6 in between those. Okay, and they drew our line of best fit for us. Now, if we were to write an equation of this would be our y-intercept. That's clearly where it's crossing the y-axis, so that would be 2.4. That's why we plug that in for b. And our slope, we're just going to estimate, right? So your slope might be slightly off from somebody else's, and that's okay, as long as you're getting pretty close. Okay, so if we look at this, we're going down 0.2 and then over 15 between these 2 points. So you just pick 2 points that are on the line. Okay, and then if we divide those, we'd get negative 0.0133, right? And that's our slope. So that's the number in front of x. Okay, so we wrote the equation of this line of best fit. Okay, and again, you might get slightly different answers on this, and that's okay. Now, we want to use the equation of the trend line to predict what might be happening in 2026. Right? Now we have to be careful because a lot of us would be like, oh, I have to plug in 26 for x because that's how long it is. But it's years after 1966. Okay? So if we do 2026 minus 1960, that gives us 66 years. Okay? So we're going to plug in 66 for x to see what her winning time might need to be. So you can see they did that here. They did negative 0.0133 times 66 plus 0.24. And if I do that, I get 1.522. So the winning time possibly in 2026 could be 1.5222, right? Now, this may change, right? Maybe skates change, right, in 2024, right, which changes some things that might give us abnormal data. Or maybe you have a really fast person, right? Maybe they're super, super fast. And that might be an outlier data. Or maybe it's a lot of slow people all together in that race. So that could change, but this is the prediction based on the data we've already received. Okay? All right, let's try another one. Assuming the trend shown in the graph continues, use the equation of the trend line to predict the average fuel consumption in miles per gallon in 2025. So we want to write this equation. And remember, this x value is years after 1980, so it's going to come into play in a little bit, okay? So first thing, I want to identify my y-intercept. And we're counting here from 12 to 18 is 6 changes, so this next line would be 15. And this next line would be 18 plus 3, which would be 21. Okay? So my y-intercept, it looks like it's about 15, okay? Again, if you were to choose 16 or 14, like I could understand that, right? We're going for approximate here. So on a test like something like this, I would look at your work and see why you chose that number, okay? And then we're looking at slope. So I know this is a point, and it appears that this is a nice point on here, right? So we're going up 3 and over 10. So my slope is 3 over 10. Again, we're approximating here, right? So if you got 3 over 9 instead of 3 over 10, not a huge deal, okay? Now, that's our trend line, okay? So they want to know what's happening in 2025, okay, because we don't have that on here yet. So first I need to decide what my x value is. Well, the x is starting after 1980, so I'm going to do 2025 minus 1980, and you can feel free to use a calculator on that, is 45, okay? So my x value is 45, okay? So then I'm going to go ahead and I'm going to plug that x value in. So we have y equals 3/10 x, which is 45 now, plus 15. And you can just go ahead and type that whole thing in the calculator. So I'm going to do 3 divided by 10 times 45 plus 15. And that gives us a nice 28.5. Okay, so the fuel consumption would be 28.5 miles per gallon. Okay. And then our convince me says, why can you use a linear model to predict the y value for given x value? And that's because the slope is a linear model, and the y value changes for each unit in the x value. Okay. All right, moving on to our next page here. So example 2, use a scatter plot to make a prediction. So if the graph is already given to us, we can kind of like just guesstimate depending on what they give us, okay? So it says find the y value for an x value of 90. So if x is 90, I'm just going to go up to my chart until I hit my line, and then I'm just going to move over until I see what that y value is, which in this case is 800. So if the temperature is 90 degrees, we can predict about 800 people at the park, right? And we could even continue this line in either direction and start making predictions, right? We could say, okay, well, 100 is right here. I could look and be like, okay, that looks like it's going to be maybe about 1,000, right? And obviously, certain things won't make sense, right? Like we couldn't have a negative temperature. We could have a negative temperature, but we couldn't have a negative number of people there, right? Which if we continued this line, eventually we would hit negative number of people, and that's not possible. Okay, so just make sure you keep that in the back of your head as you're doing that. Okay. So the scatter plot at the right suggests a linear relationship between the temperature and the number of smoothies purchased. So as the temperature goes up, more people buy smoothies. What does the rate of change or slope represent in this situation? So the rate of change describes the number of smoothies purchased for each degree of temperature. Okay, so we increase 3/5 of a smoothie every time we increase by 1 degree. Okay. What does the Y-intercept represent? So in this case, when the temperature is 0, people will buy about 8 smoothies, right? If I was looking at the temperature at 20, I'd say they buy about 16 smoothies. Okay. So what equation relates this temperature? So again, you can pick 2 points that are clearly on the line, okay? And you find the slope. You can use the slope formula, which we know is y1 minus y2 over x1 minus x2, and find the slope. Or you can count rise over run. And then the y-intercept in this case is 8. So that's why our equation is y equals 3/5 x plus 8. Okay? So let's go ahead and try another one. So a smoothie cafe has ingredients needed to make 50,000 smoothies on a day when the high temperature is expected to be 90. Should the cafe and has ingredients to make 50,000 smoothies on a day when the high temperature is expected to be 90. Should the cafe employees expect to have enough ingredients for the day's smoothie sales? So we're going to go ahead and look at this, and we're looking at the temperature at 90. So again, I'm just going to run my line up to 90. So it looks like we're skipping this would be 90 about right here. So I'm going to run my line up here, okay? And if I run it over, it looks like we would be selling about 64,000, because remember this says in 1,000, smoothies that day, okay? And sorry, I didn't read the thousands part earlier. So right now they do not have enough. No, they need at least 64,000 smoothies if this prediction is correct, right? Yeah. So you can use a graph to try and figure out what you may or may not need. So all of you who are like, Miss Hawes, when am I ever going to use this in life? If you can graph a bunch of data, you can look and make predictions about what may or may not happen, okay, to better prepare yourself. Have a wonderful day, and we'll talk to you later. Bye.